Hey everyone, welcome to our next video. We're still doing systems of equations, but now we're going to work on three dimensions. So let me get to our notes. So this is 5.2. This is systems of linear equations. But now we're going to do three variables. First, it's good to know what we're looking at. So we have this standard form. And what this is it's a plane. So when you have like an X and a Y, you're dealing with a line. Now we've added this third dimension to it, so you can think almost like a piece of paper or something. We're dealing with a plane. Also wanted to just show you what the XYZ plane looks like. So you'd have X. This is actually how we draw it. Y and Z. Kind of hard to imagine, but that's what it looks like. If you want to plot something on the XYZ plane. Now, there's a few different instances that can happen. Just like with lines, there were three options, right? With lines, they could be the same line, they could be parallel lines, or they could intersect at one point. With planes, we have some different options. Your first option is that your planes intersect at one point. And so that is going to be an XYZ point as like our answer. They can all be parallel to each other. So this means no solution. If there's no intersection, then there is no solution. The planes can intersect at a line. And so for that, we would usually, I'm going to write it in set notation, how we would write our answer, but we would say any XYZ point that satisfies these lines is one way to write the answer. And then your last is that planes are all the same. So they all overlapped, they intersect all the time. This is our infinite solutions on our plane. And usually you would write whatever the plane is. Just like for the line one, where we had infinite solutions, it was like infinite solutions on this line. We would say infinite solutions on this plane. So what we're going to be looking at is we're going to have three equations. Three variables, so three equations. And we're going to use elimination or addition, whatever you want to call it, in order to cancel out a variable. Then we'll have a system of two unknowns with two equations. Then we'll cancel out another variable. And then we'll have one equation, one unknown, and so on and so forth. So that's the idea, and I'll kind of walk you through it. So example one. I'm just going to say solve the system. So this one is x plus y minus z equals 0. 3x minus y plus 3z equals negative 2. And x plus 2y minus 3z is equal to negative 1. And so right away, we can choose what variable we would like to cancel out. And so first, I would kind of look through and just see if there's any of them that kind of point out to you that you could cancel out. But you also have to be aware that we're going to have to do this twice with two different equations. So let me repeat what we're trying to do here. I'm going to label them as 1, 2, and 3. I want to pick two of these equations and cancel out a variable. Then I will pick a different two of these equations and cancel out the same variable. So for me, I noticed straight away that 2 and 3, if I added them together, I could get rid of my z's. So I'm going to go ahead and do that. So I'm going to take 2, which is 3x minus y plus 3z equals negative 2. And I'm going to take 3, which is x plus 2y minus 3z equals negative 1. And I'm going to add these together in order to cancel out my z variable. So I'm using elimination. So the z's here would go away. I would get 4x plus y equals negative 3. What I have now created is an xy equation. So it's like I've gone from planes to now I've canceled out a variable. So now I've broken it down to just a line. But now we need to do this again. So I need to pick another two equations and cancel out z. Well, if I take 1 and 2, I can do it, but we will have to change the first one a little bit. Here, let me write it down here so that I don't run out of too much space. So now I'm going to take equation 1 and equation 2, and I'm going to again cancel out the z's. So in order to do this, I need the first one. I got to multiply by 3 so that I can cancel it out, the z's. So I would get 3x plus 3y minus 3z equals 0. And my second equation did not change at all. I add these together. I get 6x plus 2y equals negative 2. So those z's canceled out. And I'm going to label this as equation 5. Now that I have two equations with only x and y in them, I can cancel out another variable with these. So now I'll take equations 4 and 5, and my goal is to cancel out another variable. I see that if I multiplied equation 4 by negative 2, I could cancel out the y's. So I'm going to go ahead and do that. So I get negative 8x minus 2y equals 6. The bottom one I'm not changing at all. and then I'll add these together. I get negative 2x equals 4. Now I basically have a new equation, but it only has x in it. So I can divide both sides by negative 2. So this tells me that x equals negative 2. Now that we have our x value, we can start plugging back in. So if you go back and look at equations 4 and 5, those have an x and a y in them. So I can plug my x into those and solve for y. So let's see. So I'm plugging back in. To get my other variables. So if I plug into 4x plus y equals negative 3, I get 4 times negative 2 plus y equals negative 3. Negative 8 plus y equals negative 3. Add that 8 over, so I get y equals 5. So now I have my x and y. So now I need to plug into another equation that has x, y, and z so that I can solve for z. So again, I'm plugging back in. But now I want to pick one that has z in it as well. So I'm going to do x plus y minus z equals 0. I get negative 2 plus 5 minus z equals 0. I can move that z over. So this is going to give me 3 equals z. Now for your final answer here, because this is we got a point, we got an xyz point, we want to write it like that. So I'm going to write it in as an xyz point. And we got to make sure that we do x and then y and then z. Now, if you want to check your answer here, just like how you would check your answer in a 2x2 system of equations, two equations, two unknowns is what I mean by that. For that case, you would have just plugged them in and made sure it worked on both equations. In this case, you would plug all three of your numbers into all three of your equations and check that they all match. If you have time on the test, I definitely recommend doing that. Like plugging stuff back in, checking all your answers, and that kind of stuff. So again, I'm going to just kind of recap what we did because I do feel like these can be a little intense. We looked at our first three equations. We picked a variable to cancel out, and in my case, I picked z's. So I saw that with 2 and 3, I could cancel out my z's. And then I used 1 and 2 again to cancel out my z's. This results in two new equations that only had x and y in them. Then I took those, canceled out another variable, which in this case was my y, in order to have one equation with one variable. So a lot of this is just slowly canceling out variables. And then once you get one of your variables, you can plug those back in to get your other ones. So I do want to do another one of these, but I kind of just realized that my notes don't have all of them, don't have another one like this in there. So I'm going to go ahead and grab one real quick. I remember looking at the homework section for this, but sometimes, it leaves my mind what it looked like because I'll look at like the beginning of the quarter. Sorry, I'm just kind of talking. I'm pulling up the homework real quick so I can make sure I show you everything that I need to. Okay. All right, let's do one like this. Do I like that one? Yeah, let's do this one. Let's do this. This one is similar to one in my notes, but I realize that it's kind of in there. So, all right, here's my next example. So this one says 2x plus y minus z equals 1, negative 3x minus 3y plus 2z equals 1, negative 10x minus 14y plus 8z is equal to 10. So for this one, we're going to basically take the same approach. We're going to go ahead and try to cancel out a certain variable and go from there. I like to always label my equations first. So you can think which ones you think look easiest to work with. I would say if you ever notice that one of your variables is like by itself, like it has a 1 in front of it, you might want to deal with that one the most because you can multiply that by anything to cancel them out. Now, if I look at my y's, I know that I can multiply the first equation by 3 to cancel out with the second. But I'm going to have to multiply by 14 to cancel out with the third. And that just might get a little too big. I notice with my z's, I can cancel out 1 and 2 by multiplying the first one by 2. And if I multiply the first one by 8, which is just a little smaller, I can cancel out the third. So that's what I'm going to choose to do. So first, I'm going to take 1 and 2. I'm going to multiply the first one by 2. That way I can cancel out my z's. So I get 4x plus 2y minus 2z equals 2. Didn't change the bottom at all. Now I can add these together and I'll get my new equation. So this is going to be x minus y, z's are gone, equals 4. Oh, I wrote something a little weird here. That should have been a 1. I accidentally wrote a 2, so that should be a 3. Glad I have my notes here to make sure I don't write anything weird. So this is my fourth equation is what I like to label it as. And I do this just to help try to stay organized. Next, I can take 1 and 3 and cancel out my z's. You just have to make sure that you cancel out the same variable for like your first step. Now I'm going to multiply the first one by 8 in order to cancel out these z's. So that's going to give me 16x plus 8y minus 8z equals 8. Running out of space here. Move over. My second one didn't change at all. That's still negative 10x minus 14y plus 8z equals 10. Add these equations together. I get 6x minus 6y, z's cancel, equals 18. So that's now my equation 5. Now I'll take 4 and 5 and I'll perform elimination again. Now to cancel out my x's or my y's, whichever you want to think about, I can multiply this by negative 6. So I get negative 6x plus 6y equals 18, negative. The bottom one doesn't change at all. But I notice that when I'm adding these together, I get 0 plus 0 equals 0. Here's what this means. When you get 0 plus 0 equals 0, you are dealing with a dependent system. And so either one of these cases, it's either that the planes were all the same plane or they're intersecting at a line. If they were the same plane, we would have gotten 0 equals 0 a lot sooner. We would have gotten it like immediately. We wouldn't have had an equation 4 and 5. You see how with 4 and 5, we got them to be lines and then they turned into a dependent system? That means that this is intersecting at a line. That's the case that we're dealing with. So this is intersecting at a line. And a common way to write this one is to say that it's any XYZ point on the lines and we would say a y equals line and an x equals line. So for my y equals line, I'm going to use this equation. So I get y equals x minus 3. And I also need a z equation. So you need both. This is always a little bit of a weird idea, but for your z equation, you actually only want it to have x inside of it. So I have a y, so I'm going to plug that in. So instead of y, I'm writing in x minus 3. And I'm going to solve this for z. I get 3x minus 4 equals z. So here's my final answer. And in the up above, I put it in set notation, but this would be okay as well. So I know this is kind of a weird one, in my opinion. Just the way you end up writing it. It's because you're letting x kind of be your free variable. And so then you need a y equals with x in it, and you need a z equals also with x in it. So that's why we had to write it the way we did. Now, I will be honest with you, I am not, I don't plan on asking this one on the test. I just kind of want to be a bit clear about that. I think it's definitely good practice, good for your understanding. I don't plan on testing on it. We have one more type that I would like us to see, and then I think I'll do another one of just like a point as the answer. So let me write this one out for us. So this one, again, we start immediately doing what we did for the other ones. So I can label all of my equations and I'll try to cancel out a variable. I notice that I can cancel out my x's or something on 1 and 2. So let me go ahead and do that. Now if I add these equations together, I get 0 equals 0. You see how it immediately happened? That means that they are intersecting at a plane. So like all the whole planes, like all three planes are actually the same. And you could check it by doing another set as well. So if you did 2, if we multiply that by 2, I get negative 2x minus 12y plus 10z equals negative 14. And if I take 3, again, I get 0 equals 0. So with this one, it happened immediately. We didn't even get to cancel out one variable. So that's how we know that they're actually the same plane. So these are same plane. So how we would write our answer for this is we would say there are infinite solutions on the plane. And then you just write out your plane. I'm just going to take the first one. So that's the difference between B and C is with C, we immediately got that it was dependent solution. But in the B, we were actually able to cancel out a variable. We didn't get dependent until we worked with two variables, which is a line. So that's how we know, oh, they intersect at a line. Alrighty, and then I would like to just do one more. One where we actually get to completely solve it. So this is negative x plus 2y plus 2z equals 7. 2x minus 2y minus z equals negative 6. And then 3x minus 4y minus 2z equals negative 9. Now you may cancel out a different variable from me, and that's perfectly fine. I'm going to go ahead and do the y's for this one, just so that I can give you a little bit of variety. I think canceling out the z's first would also be, oh, sorry, I yawned. It would also be a good idea. But I'm going to do the y's just so that I can give you a little bit. So if I take 1 and 2, if I just add them together, I'll be able to cancel out those y's immediately. So I'm going to go ahead and do that. So I add these together. I get x, the y's cancel, plus z equals 1. So that's now my equation 4. Now I need to pick another 2, and I got to cancel out the same variable, so I need to also do the y's. If I take 2 and 3, or I could take 1 and 3. Actually, let me do that one. That one looks just a little bit easier. The reason I swapped over is because I was like, oh, I can cancel out the y's, and I don't have to multiply by a negative. So for the first one, I can multiply it by 2. So I get negative 2x plus 4y plus 4z equals 14. And from my second equation, I'm not doing anything. I'm just leaving it the same. Adding these together, I get x, y's cancel. I'll get plus 2z is equal to 14 minus 9. It's going to give me 5. So this is my equation 5. Now I can put these two together, 4 and 5, and cancel out another variable. So I have x plus z equals 1, x plus 2z equals 5. We can cancel out the x's pretty easily if I just multiply one of them by negative 1. So I'll do that to the top. I get negative x minus z equals negative 1. So I get x plus 2z equals 5. Add these together. I get z is equal to 4. So now I have one of my variables. Now I can go plug it into an equation to get my other ones. Now be careful here. If you plug z directly into either 1, 2, or 3, the issue is you're going to have too many unknowns. First, we need to plug into either 4 or 5 so that we can get a second variable. So you're kind of just going backwards from your work. So I'm going to pick the x plus z equals 1. So I'm plugging in. So I get x plus 4 equals 1. So x equals negative 3. Now I have my x value. Now that I have my x and my z, I can go plug into one of my original equations to get my y value. Trying to figure out what color I want to use. Doesn't really matter. Any of these we could plug into. So I'm going to pick, any of them look easier than the others? Maybe the first one. So I would get negative, negative 3. So I'm plugging this into equation 1. Negative, negative 3 plus 2y plus 2 times 4 equals 7. So I get 3 plus 2y plus 8 equals 7. So this is 2y plus 11 equals 7. Subtract over that 11, so I get 7 minus 11, which is 4, negative, and divide by 2, so I get y equals negative 2. So for my final answer here, remember you got to write it as a point. So it'll be negative 3, negative 2, 4. And I took this one from the homework, so I'm going to plug it in real quick to make sure I don't have any mistakes anywhere because I easily make them, so it's good to check. All right, good. It said correct. So that's going to be it for this video. Oh, I guess I didn't talk about if it was no solution, but if you have that happen, it happens immediately. Kind of like with part C, like all of a sudden you'll get like a number equals a number and they don't actually work. So if you have any questions, as always, please let me know. I would love to help you. And I will see y'all in our next video, which will actually be our last video as well. Alrighty, bye-bye. Have a good day.